Good day everyone, and welcome to another video of Mr. Frank Edu Solution. Today we are going to be having a Q&A with Mr. Franklin. Like I promised you when I did the first video on matrices, that we're going to have a session where we're going to be trying to solve questions on matrices, and that's what we're going to be doing today. Now, how do we get the order or size of a matrix? Let's quickly briefly go through that and see how we can do that. I compiled a group of matrices with their various orders. I believe that looking at this, we can now be able to obtain the order or size of any matrix. Let's look at the first matrix X. You can see it has two rows. The first row is 1, minus 8, and 5. And minus 5, 7, and 1 is the second row. Therefore, it has two rows. And it has 1 and minus 5 first column, minus 8 and 7 second column, and 5 and 1 third column. Therefore, this matrix is of the order 2 by 3. Matrix Y has two rows, 4 and 5, minus 5, and 1 column, which is 4 and minus 5. Matrix Z, this is a mistake, please. It's supposed to be 4 by 2 matrix. But when I was doing my editing, I mistakenly put 3 there. It's supposed to be a 4 by 2 matrix. You can see it's 4 rows, 5 minus 8, 5, 0, 1 minus 2, 6, 1. And F is 3 by 4. And lastly, we have a square matrix of 5 by 5. So I believe from this we can be able to easily derive the order of any given matrix without any problem. How do we show the position of matrices in elements? How do we show the position of elements in matrices? Using matrix notation. I remember talking to us about matrix notation, and I said matrix notation is used to show the position of an element in a matrix. I tried to put this small note before the example so that we can all remember what we talked about in matrix notation. And we said in matrix notation that it is going to be written with an element with a small letter with a subscript of I and J, where I is the row number and J is the column number. So you look at this example here. We have the matrix 5, 2, 7, minus 3, minus 9, minus 2, minus 7, and 11. And we're meant to find the positions of all the values. So 5 is on the first row, first column. So that we have A11. 2 is the first row, second column, A12. 7 is first row, second column, A13. And minus 3 is first row, second column. That's why it's A14. First row, fourth column. And then the minus 9 is on the second row, first column. Minus 2 is second row, second column. Minus 7 is second row, third column. And 11 is second row, fourth column. Additional notes on matrices. When I was talking about matrices the other time, we didn't add this, that a symmetric matrix. A square matrix is symmetric if its elements are such that Aij is equals to Aji. And if you quickly remember, what is this simply saying is that if we take the transpose of a matrix, the transpose of a matrix is equal to the matrix itself, as A is equals to A transpose, then you have a symmetric matrix. Looking at this example here, you can see this. If the row becomes the column, what will happen? Our first column will be 4 minus 2, 1. Second column will still be minus 2, 5, 7. And last column will still be 1, 7, 8. So if you make the row the column and you make the column the rows, you discover that you're still going to have the same matrix A, making it a symmetric matrix. So this matrix is symmetric. Now let's look at some questions on special matrices. When we talk about special matrices, we talked about the square matrix, the diagonal matrix, then we talked about square diagonal. I think and transpose. But let's look at the questions on them. Okay, now in this example, quickly, I need to make an impression. The matrix C was actually cut short during the editing. But the C was a 1 by 5 matrix, like we have 5 elements on a straight line. And the matrix G also was a 3 by 3 matrix. We have other two columns that was eliminated. Please bear with us. But I believe that we'll still be able to understand what we're trying to say, even with that. Now, the first question says, what is the dimension of each matrix? So this answers the first thing we talked about. We taught us the dimension or the order of a matrix. So for matrix A, you can see we have 2 rows and 3 columns. That's a 2 by 3 matrix. For matrix B, you can see we have 4 rows, 3 columns, a 4 by 3 matrix. And matrix C, I told you that's 5 elements. So it's 1 row but 5 columns. It's a 1 by 5 matrix. Matrix D is a 2 by 2 matrix, as you can see. Matrix E, you can see that's only 1 element, so it's 1 row, 1 column. And matrix F, we have the 4 rows and we have the 1 column. And matrix G, like I told you, is a 3 by 3 matrix. Now, what matrices are square? Basically, we said that a square matrix is a matrix where if you have m by n and m is equals to n, and we have a square matrix. So we have to just go back to the first question we answered and look for those matrices that the m is equals to the n. So you can see in D is a 2 by 2 matrix, E is a 1 by 1 matrix, and G is a 3 by 3 matrix. So these matrices are all square matrices. Then which one is symmetric? Which matrix is symmetric? And what do we say symmetric matrix is? Symmetric matrix is a matrix that if you take the transpose, you're going to get that same matrix exactly. Like I said, unfortunately, our matrix G is not complete. Matrix G was supposed to be a symmetric matrix, but I believe matrix E will just fit in for us. That matrix E, if you no matter how you turn matrix E, you still have the same element. So matrix E is a symmetric matrix. So E and G basically. Now, the example D is saying which matrix has the n3 of row 3 and column 2 equals to 11. So you can see matrix A, the row 3, okay, it cannot be matrix A because matrix A does not have row 3. Let's look at matrix B. You can see the row 3 has minus 5, minus 11, and 9, and column 2 have 2, minus 3, minus 11, and minus 1. So you can see that it meets at minus 11. So therefore, our answer is minus 11. So B is a matrix that have such. This same does not apply for any other matrix. So B is the only answer. And which matrix has the row entry of row 1 and column 3 equals 10? You can see A, the row 1, first row, the third column is 10, and also matrix B, first row, third column is also what? 10. Now, the question F says, what are column matrices? Column matrices. Which are column matrices? Basically, column matrix is a matrix that has only column. It has only columns and 1 row. So if you look at ones that have 1 row and then columns, you can see that matrix E is a 1 by 1 matrix, is a column matrix, and also matrix F is a 4 by 1 matrix. It has just 1 column. Anyone that has only 1 column is a column matrix. And we have row matrix. Row matrix is one that has only 1 rule. So you can easily see from the diagram we have there, the matrix E is a row matrix, and C, how it has only 1 rule, is a row matrix. This takes us into addition and multiplication of matrices. Now, basically, addition and subtraction of matrices are simply the same thing. Just one you are adding, second one you are what? Subtracting. And I said in the video of matrices that please, if you have, I know so I've been making a lot of references to the video I did on matrices. So if you have any confusion, you can do it to see the video. I'll add the link of the video in the description below. So you can go and watch that video and then come back and watch this one so that you gain clarity. Now you can see that we said in the video that all you have to do is to multiply the elements of A that are the same, that are the equivalent of it in B. So you can see in the first column is 9, first column of the element is 2. So you have, so because this is a minus sign, you have 9 minus 2, which gives you 7. You have minus 3 minus 5, it gives you minus 8. You have 1 minus 1, which gives you 0. You have minus 7 minus 7, it gives you minus 11. And you also have minus 4 minus 3, which gives you minus 7. And 6 minus 2, which gives you 4. Also, the same thing happened in the second example. 4 will go with 3 to give you 7, the first 3. 5 plus minus 4 will give you 1. And 7 plus 6 gives you 13. And so on and so forth. I believe the last example here shows it explicitly how we got the answer. Note, if we study the matrix both having dimensions of 2 by 3, our answer must also be what? A 2 by 3 matrix. That gives us the right to move into scalar multiplication. So this is a very simple concept. Scalar multiplication simply involves multiplying a matrix by a single number, usually a scalar. Now, for the first example, you can see minus 5 is meant to multiply the entire matrix. So what it does is it goes and multiply each of the individual elements in that matrix. You can see minus 5 we can multiply 5, minus 7, 1, 4, and 6, and then you have minus 25, 35, minus 20, and minus 30 as our solution matrix. And for the second part, what simply goes on is 2 will go into the bracket, thereby you're going to have 2 times x, 2 times x plus y, 2 times 6, and 2 times minus 2, 2 times minus x, and 2 times 1. And it's going to be subtracted by when 3 goes into the other matrix, which was highlighted there. And then when we are done, then we combine them together. You can see you have 2x here, so 2x minus 3x will give us 5x. Okay, then we're supposed to have 2x plus 2y minus 6y. You can notice that the y's will come together. So you have 2y plus 6y, which gives us 2x plus 8y. Then you have 12 minus 3 times 0, which is 12 minus 0, which gives you 12. And we have 2 times minus 2, which gives us minus 4. And the other side, 3 times 3x gives us 9x, so minus 4 minus 9x. And then we have 2 times minus x, which gives us minus 2x, and minus from 3x you get minus 5x. Then we have 2 times 1, which gives us 2, and minus 3, which gives us what? 5. Let's now look at the last thing we're going to look at today, which is the multiplication of 2 matrices. Now, we also stated this in the video, and we said that before 2 matrices can multiply, it must fulfill a certain condition. Also, I forgot to mention, please note that before the addition can take place, they must both be of the same order. I forgot to state that when I was talking about the addition. They must both be of the same order. And for multiplication of matrices, the condition is that the number of rows, the number of columns of the first matrix must be equal to the number of rows of the second matrix. The number of columns of matrix A, like in the example there, must be equal to the number of rows of matrix B. So the number of columns of A must be equal to the number of rows of B. And we can see that matrix A has column 1, 0, 4, 1, 5, 2, 6, and 3, 7, and it is equal to that of B. So knowing that, when we want to multiply, how do we go about the multiplication? So after confirming that this is multipliable, because if it's not multipliable, then we can't proceed. But after confirming, so as highlighted here, you take the first rule for matrix A, which is 0, 1, 2, 3, and then you multiply the first column of matrix B. So 0 will multiply 8, as you can see here. 1 will multiply 10, 2 multiply 2, and 3 multiply 3. And when you are multiplying, you are summing it up together, it gives us 23. Now, following that, we multiply the element along the first row of matrix A. So after multiplying the first row, we go to the second row. We take also 0, that same first row, and multiply the second column, the first row of matrix A again. We have multiplied the first column to give us the first element we have. Like if you come down to this answer, look down to the answer. That first 23 we got is the first element in the first row, first column. And if by the time we do this other guy, it will give us the second element in the first row, second column, because we're still on the first row, but we're multiplying the second column and we got 23. If you keep up with this process, the first row now we're going to multiply the third column, and I think it was explicitly laid out here. When it goes to the third column, you can please try it out yourself. We're going to get 29. And when that first row goes into the last column, we're going to have 47. Once you're done with that, next thing you have to do is you go to the second row. And when you go to the second row, same process of what happened with the first two. It multiply the first set of 8, 10, 2, 3, then multiplies minus 1, 11, minus 3, 6, and then minus 4, 0, 4, 7, and 9, 1, 5, 12. And if you can do that, drawn it out, lay it out here. If we can do this, then we're going to get the answers that we have below. It doesn't get more complex than this. This is the hardest way a matrix question can be given to you. So thank you for watching today's video. Please do well to like our video. Please like our video. Please subscribe to our channel. So let our channel grow so that we can keep dropping content and help us let our channel grow. Please like the video. Please like the video. Also, let us not forget to share with your friends and family. Share with everybody. Everybody needs this video so that they can improve their mathematics and so that they can come to my channel, which I will drop you good content that will literally help them. Also, please do not forget to drop your comments, your questions, anything you feel that's troubling you. And thank you so much for watching. We hope to keep giving you good content, and see you next time. Bye.